Good day to you all. 24G104L Engineering Practices Laboratory, Group B, Electrical and Electronics Part, Experiment 1, Residential House Wiring using switches, fuse, indicator, circuit breaker, lamp and energy meter. So this is the title of first experiment. For in that experiment, we are going to done. We need some basic apparatus required. For that apparatus required, first we need single phase energy meter. Single phase energy meter is nothing but it is used to measure the energy. This is 750 revolution constant, 240 voltage and 50 hertz. So normally in our home residential we are using single phase power supply, 240 voltage, 50 hertz. So here we are going to take a single phase induction type energy meter, and we are using two lamp. One is a fluorescent lamp, another one is a indicate LED lamp, and we are using fuse indicator lamp, connecting wires 2.5 square mm wires and 1.5 square mm wires we are used, and then one ceiling fan, circuit breaker, switches we are using for in that experiment. So this is a general circuit and layout of residential house wiring experiments. So initially we are going to take a input from in our nearby electricity post. One is a phase, red color is a phase wire, and another one black color is a neutral wire. So this is a single phase induction type energy meter. So single phase induction type energy meter having 4 terminals. So first two terminals is a input terminal received from in nearby electricity post, and another two terminal is a output terminal. That output terminal, the red color is a phase line and a black color is a neutral line. That output of energy meters, and it will be given to the input of MCB. So miniature circuit breaker. MCB is a miniature circuit breaker. That a miniature circuit breaker, we are going to take the output of red color is a phase line and black color is a neutral line. So that output taken from the MCB, it will be given to the switchboard. Here in that switchboard, one plug point available and 4 switches available, and then one regulator, fan regulators available. Fan regulators used to control the speed of the ceiling fan. Okay, so all the switches, one side we are going to connect the phase line, and another line, all the one-way switches having two terminals. All the one terminals is sorted by and connected through this phase line, and another one terminals we are going to take that in, and that line it's given to the loads, output loads, ceiling fan, light 1 and light 2. That output, this switch output is going to one plug point. So in case I am going to switch on the switch means the plug point supply will be enabled. Switch off means in the plug point supply will be disabled. The one point is connected to the phase line from that switch, and another point is connected to the neutral line. Okay, so this switch is going to connected to regulator, and regulator another point connected to the ceiling fan. The phase line connected, and another one point is connected to the neutral line. That and all same connections will be done by the lamps. Okay, so this is a general wiring connections of residential house wiring. And then fuse calculations. Generally in our house and any other places, we are going to calculate the fuse rating in correct manner. Means we are protect the equipments in our home and residential places from that any other electricity fault occur means, under high voltage and lightning strike times, we are going to protect in our equipments. Okay, so how we are going to calculate the fuse rating means, now firstly we are going to calculate the maximum demand for in our home. Okay, suppose in our home 500 watts maximum apparatus, 500 watts maximum demands of power rating if we are used means, here in the 500 watts divided by rated voltage is 240 voltage into 1.25 times of rating of that amps rating. Okay, so this is a power divided by voltage. This is a amps rating we are having. I is equal to P divided by rated voltage. So P means nothing but we are need to calculate. Suppose in our house we are using 2 ceiling fans and 2 fluorescent lamp, means 2 ceiling fans rating, 1 ceiling fan rating 60 watts, so 60 into 2 120 watts, and 1 fluorescent lamping is 40 watt, means 40 into 2 80 watts, so 120 plus 80 is 200 watts maximum we are used. Here 200 divided by 240 into 1.25 means some of the arms rating will be done. That arms rating is a suitable fuse rating of in our house. Okay, thank you.
So, voice this is an experimental setup of residential house wiring. So, this is an incoming supply. If you consider this is incoming supply, it's same as you can connect it from in your home near post. This is an incoming supply, single phase incoming supply. So before that, we are going to see the experimental setup. I'd like to explain the house wiring diagram. So phase or neutral. So this is an incoming supply received from in near electricity post, home near electricity post. It will be inputted connected to the energy meter, phase and neutral supply, and then energy meter output, phase and neutral, take it to the output, and it will be connected through fuse phase line through connected via phase to connected into the MCB. So MCB bottom side is an input supply, the top side is a output. This one is a phase, this one is a neutral. Red color is a base, black color is a neutral line. So output of the MCB, the output of the MCB directly go to the switchboard. There are no put the switchboard connection here in that switchboard. If you are using one plug point, that plug point is controlled via one single phase switch, and if you are using one ceiling fan and one fluorescent lamp, LED lamp, and then one LED lamp and one calling bulb we are using. So we have 3 switches we have to control for this ceiling fan and LED lamp, fluorescent lamp. And also here we are connected into the 2-way switch for controlling one lamp by 2 switches connected static wiring for increase. That and all we are all connected into the house wiring experiment. This is the overall circuit diagram for residential house wiring experiment. So based on that circuit diagram, so this is the input supply. That the input supply phase and neutral wire come from in our home near electricity post. It will be connected into the energy meter. This is a single phase induction type energy meter. For in that energy meter, revolution constant is 750 revolutions on 1 kilowatt hour. This is a single phase induction type energy meter. So for in that energy meter, the 4 terminals will be available. From the 4 terminals, first 2 terminals is input, second 2 terminals is output. First 2 terminals, left side is a phase wire connected and right side is a neutral wire connected. And second single phase induction type energy meter. That energy meter is used to calculate and take the reading about how much unit of we are consuming for in our home itself. Okay, so here the 4 terminals will be there. The first 2 terminals is input, second 2 terminals is output. First 2 terminals, left side is a phase input line and right side is a neutral input line. And for in this side, right side terminal is a phase output line and left side one is a neutral output line. That phase output line behind the wooden board that will be connected into the fuse wire. So fuse line, that fuse, another point, one point is connected from energy meter, another point is taken into the output, it will be connected into the MCB. So before that, that only I will explain how we can calculate the fuse rating. Okay, so fuse is used to protect the equipments. So this is a MCB. MCB is nothing but a miniature circuit breaker. It is used to protect equipments. Suppose in case any short circuit or any other fault will be occurred in our home means it's automatically tripped and to protect our equipments. Okay, so this 2 point is input line, this 2 point is output line. So left side is a phase and right side is a neutral connector. The left side is a phase output and the right side is a neutral output. That wire it will be connected through the output of the MCB connected through this electricity pipeline, PVC pipeline. It will be connected into the one switchboard. For in the switchboard, if you are using one two-way switch and two switches, one switches it will be controlled to the ceiling fan, and another one switch it will be controlled to the fluorescent light. Another one it will be fan, ceiling fan. This is a fan regulator. This is the indication lamp. This one switch is used to control this plug point power supply. Okay, so first. So through this pipeline, we are receiving one phase and neutral wire. So this is a phase line. This is a phase line. So every switches that one side it will be on series connection. This is a phase line. So another one point is one point is going to control the phase line through these switches to control the fan, and another one switches to control the lamp. And this is a three-way switches. This three-way switches. And this three-way switches, another one point, this switchboard, two-way switches, two-way switches available. For in the two-way switch, it will be interconnected through this pipeline class connections to control this lamp, one lamp through this two-way connections, two-way switches used, and one regulator, this regulators, that regulator controlled by this nearby switches, and another one point it will be directly connected to the ceiling fan. This is the indication lamp. One line is connected to phase line and another one line connected to the neutral line. This switch is used to control this switchboard. So this point is connected via this switches to the phase line. This is a neutral line. So when this switch will be on, that time that plug point, the power supply will come. Off conditions, the power supply is not connect. Okay, this is the earth point. The green color is the earth point. The earth point it will be connected to the MCB board and the energy meter board, and it will be connected into the and pointed and anyone earth surfaces, and we have to use some kind of earth rod to connect this wire. It will protect human beings from that electricity accident. Okay, so these are all the switchboard connections. From the switchboard connections, wiring house wiring through these PVC pipelines, all the wirings. So this is a three-way junction. So three ways available. This is a three-way junction. This is a clamp used to fix the PVC line pipeline into the walls and other places. This is another one of the three-way switches. This is a calling bell. So calling bell connected through this switch. This calling switch here available. So this switch is controlled to supply to the calling bell. Okay. So these are all the electricity or house wiring, residential house wiring setups. Okay. So now we go to switch on the supply from that MCB. Okay, switch on. So then it will be in off conditions. The power supply only on this side available. From that input supply, the input supply we are connected single phase energy meter and one fuse, and it will be connected to the MCB. So these are all the input phase line supply. So these are all the neutral line. It will be connected to the bottom line. So output, now the output phase did not conduct. Now only I am going to switch on the output phase line will be come from that MCB. From that MCB output phase line, here the indication lamp will be glowing. So from that switchboard, the indication lamp will be glowed. When it will be switched off, the indication lamp will not glow. Okay. So now I am going to strip the MCB. So now I'm going to switch the two-way switch. This is a two-way switch connected for in the fluorescent lamp. Here one two-way switch available. Here I am going to press. Here I am going to press another one two-way switch. It will be control this lamp, and the other one switch is ceiling fan. And the other one switch is one LED lamp. The other one switch is here one LED lamp. We control the through this single key switch, and here it is the switch of calling bell. Okay, so these are all the instruments of residential housewife. When you all come into the lab, you have to know well and know about and clear understanding of this experiment. Okay, I will be clear next slide. Okay.